Today we will study waves. Okay. Let's start with the objectives, vocabularies you will learn in this lesson. Waves, medium, sound wave, light wave, longitudinal wave, transverse wave, crest and trough will be explained. What are those all? Okay. Waves, actually, what are waves? Waves are the disturbances that transfer energy from one place to another. Here, in the definition of the waves, we are able to see that the transferring is done for just energy, not for the materials inside it, okay? The materials is not transferred, but the energy. For example, in this wave, the water molecules are not transferred, but the energy is transferred. Over here also, the water molecules are not transferred, but the just energy is transferred. The water molecules just remain in the same place. How about in the sound? Again, the air particles are not transferred, just the energy is transferred in the form of sound, in the form of voice, right? Actually, when we produce a sound, it doesn't produce any wind, yani the movement of the air particles, right? The wind is not seen when the a high amount of sound, high volume of sound is produced. It means that the energy is transferred from one particle to another in the form of vibration, but not the particles. Waves are caused by vibration of medium. A medium is the material through which a wave can travel. Over here you are able to see the vibration causes the waves, right? In the medium. Medium is the material. For example, as I said the sound is produced because of the vibration in the particles. The particles in the material moves. After that, how it is transferred? The vibration in the one material vibrates the next material, okay? The vibration in the second material vibrates the third material, and the vibration in the first particle, vibrates the second particle. Second particle vibrates the third particle, and it goes like this, and the first particle stops. Understand? The sound also actually transferred in this phenomena, we can say. Water waves are just one kind of Water waves are just one of many kinds of waves. Okay, sound and light are also waves. Actually, sound wave or light wave, water wave, all of them are wave but different types. They have different types. One by one, we will study those all. For example, on this rope, we are able to produce also what wave. When you pull it up and pull it up and down, move it up and down, you produce the wave on the rope. Actually, on the rope, the highest point on the rope, on the wave, is called crest. The lowest point on the wave is called trough, okay? The point where a wave is highest are called crest. Here is the crest, here is the crest, here is the crest, here is the crest. The point where a wave is lowest are called trough. Here is the trough, as you see here, right? A wave is a disturbance that transfers energy, you know that. Okay, some waves, such as ocean waves, transfer energy through a medium. You see, for some of the actual waves, we need medium material to be transferred. For some of the waves, we don't need the medium. Without medium, such as light waves, can transfer energy without medium. You see, actually light waves can be transferred without medium. You know that from the space, right? Actually, we get the light from sun, and in the space, it comes through the space, and we know that in this space there is no any material. There is no any solid, liquid, okay, gas. But for sound waves, we know that it is able to be transferred through the air, through the water, and through the solid materials as well. As you see, the vibration on my iPad produces the sounds, and it can be heard. You see, through the material, sound wave travels, but light waves cannot be traveled. The light waves can be transferred from with and without medium. Actually, it doesn't mean that light is transferred just in the medium. Yeah, so just without medium in the space. It means that it is transferred in the and out of the medium. Now you see here. Actually, we know that light can be transferred in the air, in the water, in the solid, all. Okay, in the space as well. For example, some X-rays can be transferred in our hands, right? We are able to see fractures inside of on our bones by the help of the X-rays, right? X-ray is also one of the ultraviolet, not ultraviolet, but electromagnetic light, right? Okay, that's all I think. We can move on. Now, not all waves transfer energy the same way. Waves can be classified by comparing the direction that they cause particles in the medium to move with the direction in which the wave moves. You see, the movement of the wave and the movement of the particles is actually very helpful to classify the waves. You see here, first of all, we should compare the movement of the particles onto this spring toy. If you want to produce the wave onto this spring toy, what do? We just move it up and down. When we move it up and down, the wave is produced. Okay. Now the particles moves up and down or forward or backward. Here, as you know, it is up and down. Do you see the particles movement of the particles? The direction of the particles moves up and down. How about here? The movement of the particles goes forward and back. When you quickly push it forward and back, what will happen? The spring toy will produce the waves. You see, actually waves are not just in the shape of the water wave. Waves also can be in this shape. Now, these are the difference of the type of the waves over here. Now, if I ask you what is the relationship between the direction of the wave and direction of the particles, you may say they are parallel each other, right? The direction of the wave, direction of the particles are parallel to each other. You see, one wire over here are moving just forward, after that backward, forward and backward. How about here, the direction of the wave, it is also forward. You see, they are parallel to each other. How about here? The movement of the particles are up and down, and movement of the wave is forward. Do you see, they are perpendicular to each other. How do we call them in different names? You see, energy can be transferred from one object to another using up and down motion. This causes energy to travel as a transverse wave. You see, the transverse wave, in the transverse wave, particles move up and down, and the wave move forward in direction. What happens? They are perpendicular to each other. They are perpendicular to each other. Particles moves up and down, wave moves forward. They are perpendicular to each other. That's why they are called actually transverse wave. Okay, this type of the waves are called transverse wave because the direction of the movement of particles and direction of the wave is perpendicular to each other. Yes, guys, how about in longitudinal wave? Energy can be transferred from one object to another using compressions. Here is the compressions, okay? Here. When the coils are closer, the path where the coils are closer, this is called actually compression. Okay, and the rarefaction when the coils are apart. When the coils are apart, that is rarefaction. Now this causes the energy travel in longitudinal wave. Guys, here in longitudinal wave, first of all, you have to know that the movement of the particles and the movement of the wave is on the same direction. They are parallel to each other. Okay. This is the longitudinal wave. How about the compressions and rarefaction? Actually, compressions is the wave which has the peak point, okay? Which has the highest point, which has the highest actually vibration or contraction, we can say under this toy spring contraction, but in the air it is vibration. Because of the sound we produce vibration. This is called compressions, okay? Then the sound is transferred from one particle to another and it becomes relaxed, it stops moving, okay? That's called rarefactions. Rarely it moves, okay? Little bit it moves. Have you understood? Now, it is, we said that sound waves are longitudinal waves. How? Actually, sound waves also longitudinal wave because the vibration of the particles are back and forth. The direction of the wave is also forward. You see, they are parallel each other. That's why that's called longitudinal wave. I hope you understood. Okay, I will explain detail here also. Look at here. How about the crest and trough of the longitudinal wave? Look, if you want to transfer it, if you want to illustrate longitudinal wave in the form of S wave, means that transverse wave, you have to draw like this. You see, the crest of the transverse wave and the compression of the longitudinal waves are on the same point. You see like this. Okay, I could draw. Let me draw again. Look, here is the crest, here is another crest, here is another crest. Here is the rarefaction, here is the rarefaction. Now, you see here? Yeah. Now, here is the what? Compressions. Here is the what? Crest. Crest and compressions are on the same line. Crest and the compression are on the same line. Actually, you may illustrate longitudinal wave in the form of S wave, in the form of transverse wave. But these are details, okay? I will not ask you how to transfer, how to illustrate it in the form of S wave. It is not important. You have to know that longitudinal wave, the direction of the particles inside of the longitudinal wave and the direction of the wave are same. They are parallel to each other. That's all, okay? And the sound wave is the great example for the longitudinal wave, we can say. Here, I want to explain on the one video as well. Here you are able to see if the sound is produced, the sound wave travels from center to the environment. Over here you are able to see the particles just vibrate and transfer energy from one particle to another. And they move back and forth, right? How about the direction of the wave? It is also forward. They are parallel each other, okay? They are parallel each other. That's why it is called longitudinal wave. How about the rarefaction? Here is the rarefaction. Do you see the particles over here between the waves, between the actual compressions, they are actually apart from each other, apart from each other, apart from each other, apart from each other. That's why the here is called rarefaction. How about the compression? Compression is here. Compression is here. You see the particles are dense over here. You may say they hit each other because of the high amount of movement of the particles. They hit each other. That's why here is called compressions. Let me ask you a question. What is the name of wave that is shown below? Now, this one. What is that? I hope everyone knows it. Yeah, it is transverse wave. So easy, right? And how about here? Which of the following does not have a medium? Definitely desk, air, water, or space. Which one? Definitely it is space. Okay, I think for this video, this much is enough. I will continue the waves in the second video. Have a nice day.